I just finished watching Lex Fridman's podcast with Neuralink's team, and I couldn't resist sharing my learnings from that, especially about UX design and how it played a key role in calibrating the brain's performance. There are many technical things which I love to break down here, but I just want to stick with UX design in this video. For that sake, I just have taken some excerpts out of the conversation with Bliss Chapman, who is brain interface software lead at Neuralink. So he works with users every day to develop these new UX paradigms. His job is to observe and monitor implants while they were getting operated. So he has this chance to watch the live signals from the brain when each electrode was getting inserted. So he was able to see those signals directly from the brain when surgery was happening. Not only him, everyone who was in the room was able to watch the live stream. Wouldn't you feel so fascinated to see those little spikes going up and down and on the tiny device that you're holding in your hand? I don't know about you, but I definitely feel so fascinated to have such an amazing experience that one can't have in their lifetime. Along with Elon Musk, Matthew and Nolan, who was Neuralink's first participant. While doing that, I got astounded by the hard work and innovation of the team behind this project. And I have noted down many learnings and understandings about technology and calibration. But the sad part is I couldn't put everything in this 10-minute video. For the people who don't know what exactly the Neuralink is a device that is implanted in brain's motor cortex. Why they have chosen only the motor cortex? Because the motive of this device is to help people who suffer from paralysis or quadriplegia in meeting their daily needs, so that they don't need to depend on some other person. And their plan is to put this device inside the motor cortex so that they get the signal when a person imagines moving his hand or finger. And this small device has some fine threads. Fine means these threads are thinner than human hair. And the robots are trying to insert these threads inside the human brain very precisely. Let us understand this deeply. The team has shown a video to Nolan and asked him to imagine doing exactly what was shown in the video. So they have detected some signals and understood some neurons were responding. Obviously, they can't decode this raw data. So they have shown the same data to Nolan and asked him to figure out how the neurons were working. So no one has any clue how he figured out a way that neurons are functioning. But after playing with that for a while, he told them that a particular neuron was firing when he imagined to move a particular finger. So this is an insane outcome, right? This gave them a path to decode the computer cursor. But the problem here is no one understands how and what exactly the user was intending to imagine. This ultimately became the biggest UX challenge because UX is nothing but empathizing with users. But here, surprisingly, no one knows what actually the user is intending to imagine. So when you start understanding this carefully, it's all about user experience. How the user is imagining any instruction and what kind of a signal he is getting back. I have no words for the people who had worked a lot of time in crafting this wonderful UX, because this is not a small thing and they have to consider tiny details to be included to get that accurate feedback. And the data that they get from the electrodes can stand only for 1 millisecond long. So the challenge here is display this 1 millisecond short signal on the screen so that any user can understand which neuron got fired and which is not. But these people, they have overcome this challenge and made it in a way that any user can understand by looking at the screen which neuron got fired and which isn't. So do you understand how important the calibration of the data is and how accurate they have made it and how precisely they designed it in a way that they are getting this accurate feedback? So before designing any UX design project, UXers will generally go through some assumptions. For example, if they are building any e-commerce application, they add the reviews and ratings for the product. Why? Because they know customer needs to trust the product before buying that. In the same way, there are some assumptions made by the Neuralink team. In one of the experiments, they have to understand the user by testing his accuracy in moving the cursor. And also, they have to display the performance on the screen. The thing is, they have displayed the positive feedback many times even though user was not accurate, and also make him feel motivated to participate in this task again and again. They have made many innovative integrations like BCI scroll that exactly replicates the performance of a normal scroll bar in computer, which helps Nolan to read manga happily. They want to give the user a natural feel so he is not forced to do something. and everything should feel normal, like he's using any computer or a digital device, but with his brain, not with his hand. I got so inspired by this amazing innovation and can't stop speaking about this. So I will end this video with 3 key takeaways that any UXer should learn from this podcast. The first thing is, an ideal UX is a one that users don't have to think about what they need to do in order to get it done. And second thing is, you can't achieve UX simply by iterating things. You have to step back and think globally. The third and the most important thing is, UX is not about what the user says. It's all about understanding the underlying problem to give what users want. Go watch this entire podcast if you have the curiosity towards innovations like me. And ultimately, don't forget to subscribe. See ya!